Hello, everyone, and welcome back to Future Engineering Lab channel. In previous videos, I showed you how to import coordinates separately in DesignModeler, SpaceClaim, and ICEM CFD. In this video, we're going to review all three methods together, compare them, and cover a few additional tips that weren't included before. Let's get started. Let's first look at the file format required by DesignModeler. The first line is just a title, so you can name it anything you like. The second line defines the column headers. Hash groups specifies the group number. Points is the point ID within that group. X chord, Y chord, and Z chord are the coordinates of each point. Each row represents a single point. In this example, all points with group 1 have a Z coordinate of 0, so they form the first cross-section. The second set of points belongs to group 2, where every point has a Z coordinate of 10, creating another cross-section 10 units above the first one. DesignModeler connects the points within each group in the order they appear in the file. That's why the point numbering is important and should follow the desired path around the profile. If you need multiple sections, simply create additional groups and assign the corresponding coordinates to each one. This method works for both 2D and 3D models. If the cross-section is constant along the Z direction, you only need to import the 2D profile first. The geometry can then be extruded or converted into a 3D model later within the software. For a closed trailing edge, the coordinate file is divided into two separate files, one for the upper surface and one for the lower surface. The upper curve starts at the trailing edge, follows the upper surface, and ends at the leading edge. The lower curve starts at the leading edge and follows the lower surface back to the trailing edge. This creates two independent curves, which can later be joined to form a closed airfoil. For a closed trailing edge, the upper and lower trailing edge points are merged into a single point. This is done by averaging their Y coordinates while keeping the same X coordinate. The shared point is then used as the first point of the upper curve and the last point of the lower curve, ensuring perfect geometric continuity. However, if you enabled the Close Trailing Edge option on the Airfoil Tools website, the trailing edge is already closed automatically, so this step is not necessary. Now let's look at the SpaceClaim format. Compared to DesignModeler, it's much simpler because it doesn't require column headers or point numbering. The first line specifies how the imported points should be connected. If polyline equals true, SpaceClaim connects the points with straight line segments, creating a polyline. If polyline equals false, or if this line is omitted, SpaceClaim creates a spline instead, generating a smooth curve that passes through the points. Each row then contains 4 values: the group number, X coordinate, and Y coordinate. Since this is a 2D format, no Z coordinate is required. All points with the same group number belong to the same curve, while a different group number starts a new curve. The 3D format is even simpler than the 2D format. The first line, 3D equals true, tells SpaceClaim that the file contains 3-dimensional coordinates. As mentioned earlier, the second line controls how the points are connected. If polyline equals true, SpaceClaim creates a polyline by connecting the points with straight segments. If polyline equals false, or if this line is omitted, SpaceClaim generates a smooth spline passing through all the points. After these two settings, each row contains only 3 values: the X, Y, and Z coordinates of a point. Unlike the 2D format, there is no group number, because this file defines a single 3D curve. SpaceClaim simply reads the coordinates one by one and creates the geometry in the same order they appear in the file. Now, let's talk about ICEM CFD. ICEM curve format. The first line contains 2 numbers. The first number is the total number of points in the file, and the second number specifies the curve type. In this example, 35.2 means the file contains 35 points, and those points will be imported as 2 curves. Each subsequent line contains the X, Y, and Z coordinates of a point. ICEM reads the points sequentially and automatically creates a curve passing through them. ICEM points format. The points format is even simpler. There is no header and no point count. The file contains only the X, Y, and Z coordinates of each point. When this format is imported, ICEM creates independent points without connecting them into a curve.
That's it for today. Thank you so much for watching Future Engineering Lab. If you found this video helpful, please give it a like and subscribe to the channel for more ANSYS tutorials and tips. Take care.